All right, and welcome back. So if you watched the first video, you know exactly what we're doing. So picking up right where we left off, let's look here at what if I compose sine with tangent inverse of 1? Again, tangent inverse of 1 is some angle theta. So let theta be tan inverse of 1. That means that tangent of theta is 1, and theta itself must be in either quad 1 or quad 4. So where is tangent equal to 1? Well, it's at pi over 4. So what is sine of pi over 4? Root 2 over 2. Hence, sine of tangent inverse of 1 is root 2 over 2. Notice I give you a trig value into your inverse function and then put that into your trig function and you get a trig value back. Whereas earlier when I was composing here, I put an angle in to sine, and then I composed it with sine inverse, and I got an angle back out. Alrighty, so back to where we were. Let's look at just a couple more examples, and then you're going to get to try some on your own. So, arc cosine of tangent of pi over 4. So, again, arc cosine is the same thing as cosine inverse. Tangent of pi over 4, again, that's going to be 1. So what's cosine inverse of 1? Well, that's going to equal some theta. So that cosine of theta equals 1. Again, where is cosine equal to 1? That's right at 0 radians, or 0 degrees. So arc cosine of tan of pi over 4 is 0. Tan inverse of cosine of pi. Again, cosine of pi is -1, so this is going to be tan inverse of -1. That is some angle theta, so that tangent of theta is -1. So where is tangent -1? Again, tangent, since I'm originally starting with tan inverse, my theta has to be in either quad 1 or quad 4. So in quad 4, it's negative pi over 4. Negative pi over 4. Alrighty? So I would normally say any questions, but you're watching a video, so sadly if you have questions, you're just going to have to pause and rewatch and or email me. But for now, I'm going to assume there's no questions, and you try, right? Evaluate the following compositions without a calculator. So example 4 has A, B, C, D, and E. So please, right now, pause the video and attempt these on your own. Like this, pause. All right, good. Now that you've tried them on your own, let's go through them together. Again, sine of 7 pi over 4, if we think about that, so there's 1 pi over 4, 2, 3, 4, 5, 6, 7 pi over 4 is way over here in quad 4. Sine of 7 pi over 4, sine in this case is going to be negative rad 2 over 2. Cosine inverse of negative rad 2 over 2. So notice it's cosine inverse now, not sine. Where is cosine going to be negative in either quad 1 or quad 2? So where is cosine inverse going to be negative root 2 over 2? It's going to be negative rad 2 over 2 for theta equal to 3 pi over 4. Right, that's where I'm going to have my reference angle of 45 degrees. So this is 3 pi over 4. All right, this one, sine of tan inverse of -1. Again, when you see tan inverse, since it's still new, if it helps, think of this as some angle theta. So where tangent of theta is equal to -1. When is that going to happen? Again, tangent is going to be negative in quadrant 1. Tangent of theta is going to be -1 when theta is negative pi over 4. So this is sine of negative pi over 4. So what is sine of negative pi over 4? Sine of negative pi over 4 is negative root 2 over 2. That angle there would be negative pi over 4. Negative pi over 4 is my angle there. Okay. How about arc cosine of tangent of 0? Okay, so tangent of 0. What's tangent of 0? Well, tangent of 0, sine is 0 and cosine is 1, so tangent of 0 is 0. What is arc cosine of 0? So again, arc cosine is cosine inverse of 0. Again, that's going to equal some theta. when cosine of theta equals 0. So where is cosine equal to 0? In between quads 1 and quads 2, it's equal to 0 right here, right up here on the unit circle at pi over 2. So theta is pi over 2. So this whole thing is equal to pi over 2. Our cosine of 0 is pi over 2. Continuing on, right? Tan inverse of cosine of negative pi over 2. Okay, so cosine of negative, so negative pi over 2 is down here. So what is cosine at negative pi over 2? It's 0. Tan inverse of 0. Okay, so again, when is tangent equal to 0? So this is like saying this is equal to some theta, where tangent of theta equals 0. Tangent of theta equals 0 at 0. 0 degrees radians, right? At 0 degrees or 0 radians. All right. And last but not least, cosine inverse of cosine of 5 pi over 3. Now, is this just going to be 5 pi over 3? Well, it would if 5 pi over 3 was between 0 and pi, but it's not, right? 5 pi over 3, so there's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, right? 5 pi over 3 is over here. Cosine in that case is going to be positive 1/2. So where else is cosine equal to positive 1/2? Right, so what, if this is my theta, then cosine of theta equals 1/2, most easily in quadrant 1 with the reference angle pi over 3. Alrighty. So those are our solutions there. So now we have not even graphed all of our inverse functions yet, but we're going to apply some transformations to them. So what do we know? Cosine inverse has a domain of -1 to 1 because that's the range of cosine. And it has a range of 0 to pi because that's what we're restricting the domain of cosine to be. So using just this much, what happens when I have 3 times cosine inverse of 4x? Well, again, 3 is going to be a vertical stretch. So a vertical stretch is going to affect my range. So my range is going to be from 0 to 3 pi. And this 4 on the inside of my function is a horizontal shrink of 1/4. So it's going to horizontally shrink. So instead of a domain of -1 to 1, I'm going to have a domain of -1/4 to -1/4. Likewise, tan inverse of x. So again, think about your tangent graph that looks like this, right? The domain restriction of tangent is our range restriction for tan inverse from negative pi over 2 to positive pi over 2. And the range of tangent, which is all reals, is going to be the domain of tan inverse. So what happens if I multiply tan inverse by -5 and on the inside I divide by 3? Well, again, the 0.5 is going to be a vertical shrink of 1/2. So vertical shrink, that has to do with my, again, range. So instead of negative pi over 2 to positive pi over 2, if I take half of each of those, that's going to be negative pi. Ooh, shame, shame. Tangent has parentheses, right? I do not actually include pi over 2 and negative pi over 2, right? That's where I have asymptotes. So when I look at the graph of tan inverse, so please fix that, right? I'm not including negative pi over 2 and positive pi over 2 in the actual range. You never actually get there. But vertical shrink of 1/2 is going to bring my range down to negative pi over 4 to positive pi over 4. And here, right, since I'm dividing by 3, that's the same thing as having a horizontal stretch of 3. Is that going to affect the domain? Well, the domain was all reals, so it's still all reals. All right, so look at these two and give them a try. Describe in words what transformation is going to be happening to your trig functions, right? Your inverse trig functions, right? So if y is equal to sine inverse of x generally, this usually has a domain of what and a range of what. What is happening to sine inverse? when I have a -2 in front and a 3 on the inside? And then how does that affect the domain and range? And then likewise do this one. So pause, please pause and try these on your own. All right, did you get this? All right, so for C, the -2 means we're going to reflect over the x-axis and have a vertical stretch by 2. The 3 on the inside means a horizontal shrink by 1/3. So again, horizontal shrink, that's going to shrink up my domain to -1/3 to +1/3, right? And that reflect over the x-axis first, it would basically be +π/2 to -π/2, but with our range, we always list it negative to positive. So that's not going to do much here, but then that stretch by 2 means multiplying both of those by 2 is going to give me -π to +π. All right. This one, negative cosine inverse of x/2. I'm going to reflect over the x-axis. That's what the negative is going to do. And I'm going to have a horizontal stretch by a factor of 2. So that horizontal stretch is what's going to change my domain from -1 to 1 to -2 to 2. And that reflection over the x-axis now, instead of my range being entirely above the x-axis from 0 to pi, I'm going to be reflected, and it's going to be from -π to 0. All right, so again, let's actually look at a graph, and let's graph these inverse trig functions, right? So use the domain and range of the inverse trig functions to sketch their graphs. So again, sine inverse of x. What do we know? This is true if and only if, right, sine of y equals x, where y, again, the range is going to be in between -π/2 and +π/2. So here's π/6, that's right there. So here's 2π/6. Here's 3π/6 is π/2. So that's the top. Again, π/6, 2π/6, which is π/3. And down here is my -π/2. So my range is going from up here to down here. Now, what is the domain of sine inverse? Again, my domain is going to be from -1 to +1. My range is going to be from -π/2 to +π/2. So my domain is from -1 to 1. So this is 1/4, 2, 3, 4. So this is 1. 1, 2, 3, 4. This is -1. So my entire graph lives kind of in this little square here. So what do we know? Sine of 0 is 0. So sine inverse of 0 is also 0. So I'm going to be right here through the origin, right? And if it helps, right, it might actually be helpful. What does your sine function look like? Y equals sine of x, right? It goes like this, and it goes like this. So if we're going to think about concavity, I'm concave down here, and I'm concave up on the back side. When I'm graphing the inverse, right, I'm going to be flipping it over, right, that line. So that's going to flip the concavity. So in this case here, sine inverse of 1, that is π/2, because sine of π/2 is 1. Again, call this π/2, that's 1, right? And likewise, sine of -π/2 is -1. So sine inverse of -1 is -π/2, right? Why did I choose π/6? Because what is sine of π/6? It's 1/2. So sine inverse of 1/2 is going to be π/6. Likewise, right? So do we see sine is concave down over here, but the reciprocal, not the reciprocal, sorry, the inverse function is going to be concave up right here. So sine is concave up on the right side and concave down on the left side. Again, it's the reflection of this piece of the sine graph, right? This is the rest of my sine graph. It's the reflection of this piece over y equals x. So very similar, but this is concave up, this is concave down. So that's sine of x. So try right now to do cosine and tangent on your own. And this is what the graph of your inverse cosine and inverse tangents should look like.